Welcome to the deep dive. We cut through the noise, get you informed on key topics fast. Today, we're diving into something that's, well, it's everywhere. It's become so tangled up in our daily lives, it's almost invisible. I'm talking about the technology we interact with constantly. Computers used to be these massive things, room size, only for specialists. Now, they're in our pockets, on our wrists. They're just woven into everything.
It's a huge shift, yeah. And this ubiquity means interacting with tech isn't just for the experts anymore. It's basic daily life for pretty much everyone. And because you, our listener, like everyone else, are busy, you don't really have time to sit down and learn a new system.
Right. No time at all.
So the tech has to be intuitive. It's got to be easy to pick up and, maybe most importantly, as error-free as possible.
Exactly. So our mission today is to really unpack these critical fields: human-computer interaction, HCI, and user experience, or UX. We're going to explore not just how we interact with technology, but why good design is so absolutely vital. We're talking impacts ranging from, nuclear power plant control rooms all the way down to the label on your cleaning supplies.
Yeah, and we've pulled our insights from a pretty comprehensive lecture overview, some related articles too, basically giving you a shortcut to getting informed on this really critical topic. This deep dive should hopefully reveal some of those unseen forces that shape how you use tech every single day.
Okay, so with that picture of how tech has evolved, let's really zero in on the academic field behind it all. Human-computer interaction, HCI. What exactly is it at its core?
Well, fundamentally, HCI is the study of how people, humans, interact with computing technology. It breaks down into three parts, really. There's the human, that's the end user, you, or anyone in an organization using the system. Then the computer hardware, software, the whole package. And finally, the interaction itself. That's the transfer of information between the person and the machine.
Okay, so it's about that connection point.
Right. And there's a formal definition from HCI, a big professional group back in '92. They called it a discipline concerned with the design, evaluation, and implementation of interactive computing systems for human use and with the study of major phenomena surrounding them.
That sounds broad.
It is broad, and it highlights that HCI goals aren't just about, building stuff. It's about making it usable, creating software and interfaces that work well, improving the ones we already have, and even figuring out new problems that software could potentially solve.
Given how complex people are, our psychology, how we think it can't just be computer science involved, right? What else had to come into play?
Oh, absolutely. That's a key point. HCI is inherently interdisciplinary. It's got to be. It pulls from computer science, obviously, but also engineering, psychology, the social sciences, design. Each one brings a vital piece of the puzzle, understanding how people think, how groups interact, how to build things effectively.
Yeah.
Without that mix, the design just wouldn't work as well.
That makes total sense, especially when you think about how we've actually interacted with computers over the years. It's changed dramatically. Like back in the 50s, the interface was literally hardware, flipping switches on panel.
Yeah, hard to imagine now.
And then the 60s, 70s, it moved to programming level, COBOL, Fortran. 70s to 90s, we got terminals, command lines, typing everything in. Seems so clunky now.
It really does. But then the 80s, that was a big leap. The interaction dialogue level, graphical user interfaces, GUIs, multimedia started appearing.
Windows, Mac.
Exactly. Then the 90s shifted focus more to the work, setting networks, groupware, collaboration tools.
Right.
But the real explosion, I think, was the 2000s. Interfaces became truly pervasive. Think RF tags, Bluetooth, mobile phones, consumer gadgets, embedded tech everywhere.
Right. The interface wasn't just a screen on your desk anymore. It was suddenly part of, well, everything.
Yeah.
Often invisible.
Precisely. Integrated into our lives.
And that journey from switches to smartphones really underscores how the experience of using technology became just as important as what it could actually do. Which brings us nicely to user experience. UX, it's more than just where you click, isn't it?
Oh, much more. Don Norman and Jacob Nielsen, they're pioneers in UX. They define it as encompassing all aspects of the end user's interaction with the company, its services, and its products.
All aspects. So beyond just the app itself.
Yeah, that's the crucial part. It's the whole journey. It means you have to deeply understand your users. What do they need? What do they value? What are their abilities, their limitations? But importantly, it's not just about the user in isolation. You also have to balance that with the business goals and objectives. Good UX tries to, improve the quality of that whole interaction and really shape how the user feels about the product and the company.
Okay, so how do we break that down? Peter Morville, another key thinker here, lay out 7 factors for good UX. What are they?
Right. Morville's honeycomb. It starts with the most basic, Is it useful? Does this thing actually serve a purpose?
Makes sense. Useless tech isn't good UX.
Exactly. Then, is it usable? Can people actually achieve what they want to do effectively, efficiently?
Okay.
Third, is it findable? Especially online, can people easily locate the information or features they need? Navigation, search, that kind of thing?
Right. Nothing's usable if you can't find it.
Precisely. Then, number 4, is it credible? Can users trust the product, the information, the company behind it?
Trust is huge online.
Absolutely critical. Fifth, is it desirable? Does it have that appeal? Does it stand out? Does it create a positive emotional connection that makes people want to use it over other options?
Ah, the cool factor, maybe. Or just good aesthetics.
Partly, yeah. Aesthetics, branding, image. Sixth, and this is increasingly vital, is it accessible? Can people with a whole range of abilities, including disabilities, use it effectively?
Accessibility. We'll
Yeah.
definitely need to dig into that more.
We will. And finally, the seventh factor, which kind of underpins everything. Is it valuable? Does it deliver real value, not just to the user, but also to the business providing it?
So useful, usable, findable, credible, desirable, accessible, valuable. That's quite a list to balance.
Yeah.
Where do designers often run into trouble balancing those? Like desirability versus explorability?
That's a classic tension, you're right. Sometimes making something look really sleek and minimalist, which can increase desirability, might accidentally make it harder for someone with, say, low vision or motor difficulties to use. The key is really integrating accessibility thinking right from the start, not treating it as an add-on.
So bake it in.
Exactly. Use inclusive design principles, allow for customization, make sure the code works with assistive tech. It isn't about making things ugly for accessibility. It's about expanding our idea of what good, effective design means for everyone.
And these factors, this balance, it's not just theoretical. When design fails, the consequences can be incredibly serious, sometimes devastating. The 3 Mile Island accident, March 28, 1979. That's a really sobering example, isn't it?
It truly is. A partial meltdown of reactor number 2. It was rated a 5 on the International Nuclear Event Scale, which is serious. And when they investigated, they found major issues with human factors and, specifically, the user interface design in the control room.
What was the specific problem?
Well, operators relied on a control panel light. They believed this light indicated that a certain valve was closed, but the light only showed if the power was going to the solenoid controlling the valve, not the actual physical position of the valve itself. And the valve was stuck open. So the interface was giving them false information. Because of that, they couldn't correctly diagnose the problem for hours. It turned what should have been a manageable issue into a major nuclear incident.
Wow. A single misleading light. That's terrifying. It just hammers home how a small design flaw in a critical system can lead to catastrophe through human error.
Precisely.
And it's not just these huge complex systems. We see high stakes even with everyday things, like cleaning products.
Yeah, the Fabuloso example is often cited. It's a multipurpose cleaner, but the packaging is very colorful. It looks almost like a beverage.
Right, I've seen it. It does look appealing.
Too appealing, maybe. Tragically, this has led to accidental ingestions. A study back in 2006 looked at just 4 months of data from Texas poison centers and found 94 cases. People mistook it for something drinkable because of the design.
94 cases in 4 months. Just in Texas. That's shocking for a cleaning product.
It highlights how even seemingly simple design choices, like packaging color and shape, can have serious safety implications if not thought through carefully.
And you mentioned the USS Vincennes incident, too, shooting down a civilian airliner. Another case where interface design was implicated.
Yes, that's another well-documented tragedy where the complexity of the information display and the interface used by the crew were considered contributing factors in a high-stress, rapid decision environment. These aren't just abstract design problems. They have real, sometimes tragic, human costs.
Okay, so given these high stakes, given the complexity, how do we actually build things well? How do we prevent these failures in design effectively for humans?
That really leads us to the philosophy and practice of user-centered design, or UCD.
User-centered design. What does that entail?
It's essentially an iterative design process. That means it's a cycle, not a straight line. And throughout that cycle, the designers are intensely focused on the users and their needs at every single stage.
So users are involved directly.
Absolutely. You involve users throughout the process, using all sorts of research methods, interviews, observation, testing prototypes to make sure their voice is heard and understood. The goal is to create products that aren't just functional, but are highly usable and genuinely accessible.
And there's a real payoff to doing this, right? I read something about the ROI.
Oh, the return on investment can be huge. Some studies suggest every dollar invested in UX and UCD can yield returns of anywhere from $2 to even $100.
Wow, up to $100 back for every $1 spent.
Sounds incredible. But when you think about reduced development waste, lower support costs, increased sales, increased user productivity, it adds up fast. Focusing on the user pays off.
Okay, so it's an iterative process. You said it's a cycle. What are the typical phases in that UCD cycle?
Generally, it's broken down into 4 key phases. And remember, you loop through these. First, you understand the context of use. You really dig into the conditions, the environment, the situations where people will actually use this system.
Get the real-world picture.
Exactly. Second, based on that understanding, you identify and specify the user requirements. What do they actually need to accomplish? What are their goals, their constraints?
Okay, context first, then requirements.
Then, phase 3 is designing solutions. This is where the creative work happens, developing prototypes, interfaces, workflows based on those requirements.
Making the thing.
Right. But it's not the end. Phase 4 is crucial. Evaluating the outcomes. You test the design with real users. In that context you identified against those requirements. Does it work? Where does it fail?
And then you iterate. Go back based on the evaluation.
Precisely. You take what you learned from the evaluation and loop back, usually to the design phase, sometimes even earlier if you misunderstood the context or requirements. You refine and reevaluate until the design meets the user's needs effectively.
It sounds like a really thorough approach, a lot more deliberate than just building something and hoping it works.
It is, and the advantages go way beyond just making something that looks nice or is easy to click.
What are the main benefits you see from really embracing UCD?
Well, first, as we touched on with the ROI, it clearly leads to increased sales and lower customer service costs. Products that genuinely meet user needs sell better, and users run into fewer problems, meaning fewer support calls.
Makes business sense.
Definitely. Second, and critically important given our earlier examples, it leads to safer products. When you design for specific contexts and tasks, considering potential errors, you drastically reduce the risk of things going wrong, especially in high-stakes environments.
Safety through design.
Exactly. And third, UCD forces designers to think about all potential users. This helps in recognizing and accommodating human diversity, different abilities, different cultural backgrounds, different values. It leads to more inclusive products that work better for more people.
Okay, understanding the user is key, but you mentioned context as the first phase of UCD. Let's dig into that a bit more. What does context really mean when we talk about HCI?
Right. Context in HCI is all about the actual conditions under which someone is using a system. It's not just the user in isolation, but how the system interacts with them in their real day-to-day life. Understanding context is vital for doing accurate usability testing in user studies. You need to test in realistic situations.
So it's not just testing in a lab.
Ideally, no, or at least supplementing lab tests. There are generally 4 key types of context that designers need to think about.
Okay, what's the first one?
First is user context, sometimes called personal context. This is all the specific information about the end user themselves, things like their profile age, maybe their preferences, but also their real-time location, whether they're inside or outside, maybe even their orientation. It can also include who they're with, nearby objects, the social situation. All that personal stuff matters.
Okay, so who the user is and what's immediately around them. What's next?
Second is time context. This covers anything related to time. The absolute time, the date, day of the week, maybe even the season.
Like how my calendar app needs to know the time zone.
Exactly. That's a perfect example. A calendar that automatically adjusts your appointments to the correct time zone when you travel is using time context to adapt and be more useful.
Got it. Third type.
Third is physical context. This includes measurable aspects of the environment around the system. Think temperature, noise levels, lighting conditions, maybe even traffic nearby.
Ah, like how my phone screen brightness adjusts automatically.
Precisely. The ambient light sensor in phones, like the old iPhone 3G had, that adjusts the display based on surrounding light. That's a classic example of adapting to physical context for better usability.
Makes sense. And the last one.
The fourth is computing context. This covers everything about the computational resources available at that moment. So what networks are available, what's the bandwidth like, are there communication costs involved, what other devices or resources like printers are nearby.
So how the device itself is connected and performing?
Right. For example, your phone might sync everything when it's on fast Wi-Fi, but only sync essential stuff when it's on a slow or expensive mobile connection. That's using computing context. Or think about how your phone might dim its screen after a period of inactivity to save power. Or how some phones answer a call automatically when you lift them to your ear. Those are context-aware interactions based on computing state or sensors.
Okay, so user, time, physical, and computing contexts. Designers need to think about all four.
Ideally, yes, to create truly adaptive and intuitive experiences.
Beyond these sort of technical contexts, there are bigger societal issues that really shape how HCI design happens, aren't there? Things like privacy and security seem more important than ever.
Oh, absolutely critical. Privacy and security concerns force designers to be really careful. It means using clear, unambiguous language, choosing sensible default settings that prioritize privacy, designing icons that people understand intuitively, and sometimes building complex layered interfaces like for online banking or secure voting systems. It's all about building and maintaining user trust.
And what about education? How does computer literacy, or lack thereof, affect design?
That's a huge factor, especially globally. Think about why digital learning hasn't completely taken over in all schools, even when something like a pandemic might seem to push it. Often it comes down to basic computer literacy levels, access to devices, and internet. So interfaces for education, particularly in some government schools or less developed areas, need to be incredibly simple, robust, and maybe rely less on text, more on visuals or voice.
Business needs must be a huge driver too, right? Pushing for new kinds of interaction.
Definitely. Globalization, the rise of e-commerce, e-marketing, remote work, e-learning, all these massive shifts are driven by business needs, and they all rely fundamentally on good HCI. If the user experience is bad, those ventures just won't succeed. The interface is the business in many cases.
It's also interesting how different groups might interact differently. What about gender? Is there evidence that men and women approach or experience technology differently?
Well, this is a complex and sometimes controversial area, but research from fields like psychology and even neuroscience does suggest some general differences in how men and women might communicate, solve problems, or process information. This can translate to differences in perception or preference in software. Some studies, for example, suggest women might, on average, prefer more collaborative or communicative approaches, maybe respond better to certain aesthetic styles, or value different kinds of rewards in games compared to men.
So, not stereotypes, but maybe tendencies designers should be aware of.
Exactly. It's about recognizing potential differences to create broader appeal, not pigeonholing. Being aware of these nuances helps design for a wider audience.
And age differences seem like they'd be even more pronounced. Designing for a child versus an older adult must be completely different.
Oh, massively different. Let's take children. Their needs change rapidly as they grow. Toddlers have developing motor skills, low literacy, short attention spans. They need bright, colorful, image-heavy interfaces, things that are easy to touch or manipulate. Robustness and parental controls are key.
Makes sense.
Teenagers, on the other hand, can handle complexity. They often enjoy challenge, competition, social features. They can learn independently, so interfaces for them can be much richer, more demanding.
And then the elderly. What are the key considerations there?
For older adults, communication is often a primary motivator for getting online email to stay connected is huge, especially if mobility is an issue. But designers have to account for potential declines in motor skills, making buttons larger, targets easier to hit, and cognitive changes, maybe simplifying navigation, using clearer language. Vision and hearing changes are common too.
So, difficulty with pointing devices, maybe, or reading small text.
Yes, exactly. Trouble finding information, getting confused by multiple windows, difficulty with precise mouse movements. Errors can also be more stressful or discouraging if confidence is lower. Good design for older adults often involves building in flexibility, allowing users to easily adjust font sizes, contrast, sound levels. Customization is key.
Government rules also play a part, don't they? Like accessibility laws.
Absolutely. Things like EEOC laws regarding disability access in the U.S. or similar mandates elsewhere directly impact how public-facing websites, especially government sites, must be designed. They have to ensure everyone, regardless of ability, can access services and information. This drives specific design requirements for accessibility, and things like national ID cards also bring unique HCI challenges for security and usability.
The sheer variety of technology now must also be a huge factor. We're not just talking desktops and laptops anymore.
Not at all. Think RFID tags, wearable computing like smartwatches, the explosion of mobile devices, ubiquitous computing where tech is embedded everywhere, context-aware systems that react to your situation, and then there's social computing, social networks, massive online games, virtual worlds. Each of these requires different design thinking, different interaction paradigms. It's an incredibly diverse landscape.
And what about extreme situations, emergencies, disasters? How does HCI help there?
That's a critical application area. Visual analytics is a field that uses HCI principles to design interfaces for high-pressure, information-rich situations like natural disaster response or counterterrorism. The goal is to create interfaces that provide situational awareness quickly, combining maps, network data, timelines, alerts, all in a way that humans can rapidly understand and make critical decisions under stress. Design can literally save lives here.
Wow. And then there are just other needs, right? Personal stuff, cultural
Yeah,
factors.
absolutely. Things like the need to reduce social isolation, which drives social computing, accommodating personal preferences and values, and critically, recognizing cultural differences and the huge spectrum of human diversity. All of these feed into the complex challenge of designing technology that truly works for people.
Okay, that mention of cultural differences feels really important. We live in a globalized world. You can't just design for one culture, can you? Multicultural interaction must be a huge challenge.
It is, and honestly, it's an area where many software companies still fall short. Often, other cultures are treated as an afterthought, sort of localized poorly, forcing users to adapt to an interface that doesn't feel natural or intuitive to them.
Which leads to frustration, probably lost users.
Definitely. Good multicultural design needs careful attention right from the start. It's about language, yes, but also colors, layouts, how information is structured, the symbols you use, overall cultural sensitivity.
Can you give some specific examples, things designers often get wrong or need to consider?
Sure. The obvious ones are language localization, getting translations right in date and time formats. Is it month, day, year, or day, month, year? That trips people up constantly.
Right.
Then there's reading direction. Designing for left to right languages like English is standard, but what about right to left like Arabic or Hebrew, or even vertical text?
Yeah.
The entire layout has to change.
That's a big one.
Huge. Also, numeric formats, currency symbols, weights and measures, they all vary. Even how you format phone numbers or addresses. Things like names and titles, Mr., Mrs., Mrs., Doctor, etc., differ culturally. Capitalization rules, punctuation norms.
What about visuals, colors, symbols?
Very important. Colors have vastly different meanings. White might be for weddings in one culture, funerals in another. Red could mean danger, luck, or celebration. You have to research. Symbols are tricky too. Everyday objects, animals, gestures like a thumbs up, they can have completely unintended or even offensive meanings elsewhere. You can't assume universal understanding.
So even a simple icon needs careful thought.
Absolutely. And beyond visuals, think about tone and formality. How direct should the language be? What level of politeness is expected? Metaphors used in interfaces like a shopping cart might not translate well if the concept isn't familiar.
It sounds like a minefield if you don't pay attention.
It can be. Even sorting order for lists can differ based on alphabets or cultural conventions. Getting these details right shows respect for the user's culture and makes the product feel like it was made for them, not just translated.
Okay, all of this diversity, cultural, age, ability leads us to perhaps one of the most vital areas, accessibility. Designing for everyone.
Yes, accessibility is about designing applications so they are genuinely usable by people with disabilities, or maybe otherwise abled is a better term. Often this involves using multimodal systems that offer information and interaction through different channels like sound, sight, touch.
How do designers approach different types of disabilities? Let's start with visual disabilities.
Right, this covers a spectrum from maybe long-sightedness to complete blindness, and also color blindness. For users who are blind or have very low vision, solutions include things like Braille keyboards, screen reader software that reads web content aloud, screen magnifiers to enlarge parts of the display. Simple things like using large enough fonts and avoiding thin lines are crucial.
And color blindness. You mentioned that affects quite a few people.
It does. Around 8% of men, maybe 0.5% of women, have some form of color vision deficiency. Most common is red-green confusion, protanopia, or deuteranopia. Less common is blue-yellow, tritanopia. This means designers absolutely cannot rely solely on color to convey information. You need secondary cues, text labels, icons, patterns. Palettes need to be chosen carefully, so contrasts work for everyone.
Okay. What about auditory disabilities? Hearing impairment or deafness?
For auditory disabilities, the main approach is providing text alternatives for any audio content. That means accurate transcriptions for audio clips, podcasts, etc., and importantly, captions for videos. It's about ensuring the information is accessible through sight, if not sound.
Makes sense. And motor disabilities? People who might have trouble using a keyboard or mouse due to mobility issues?
Here, flexibility in input methods is key. Offering robust speech recognition for voice input can be a great alternative to typing. Features like sticky keys, where modifier keys like Shift or Control stay active after being pressed once help with one-handed typing. And for those with more severe motor limitations, eye-tracking devices allow cursor control and interaction using just eye movements. It's about providing alternatives to traditional physical input.
That's amazing technology. Finally, cognitive disabilities. This seems like a really broad category. Learning disabilities like dyslexia, maybe autism, limitations in memory or problem solving. How do you design for that?
It is broad and challenging. The core principle is often clarity and consistency. Use simpler language where appropriate. Keep layouts predictable and navigation straightforward. Reduce clutter. For users who have trouble visualizing structure, providing a clear sitemap or always showing the navigation path, breadcrumbs, can help orient them. For dyslexia specifically, using clear fonts, good spacing, and maybe highlighting key information can aid readability. Some suggest allowing users to easily select text to have it read aloud. And for anyone who struggles with spelling, incorporating a good spelling checker with helpful suggestions is vital. It's about reducing cognitive load and potential frustration points.
It's impressive how many specialized tools and techniques exist. Can you mention any specific examples of assistive tech or browsers that stand out?
Well, there are dedicated browsers like BrailleSurf, which you mentioned, offering speech, braille output, and large text altogether. That multimodal approach is powerful. But I also think some of the most innovative stuff is becoming mainstream, like how smartphones use sensors detecting you've lifted the phone to your ear to answer a call. That reduces the number of steps, the cognitive effort required. While designed for everyone, it provides particular benefit to users with certain motor or cognitive challenges. It shows accessibility features often just make things better for all users.
That's a great point. Universal design benefits everyone. Okay, so we've covered a lot. HCI, UX, UCD, context, social factors, accessibility. Bringing it all together, what's the big payoff? Why should businesses, developers, everyone really invest in doing this well?
The benefits are really significant, and they ripple outwards. First, as we said, it leads to increased productivity. Users can get things done faster and more easily. Second, it drastically reduces the need for training and support. If a system is intuitive, you don't need thick manuals or constant help desk calls. The product basically teaches itself.
Saves time and money.
Big time. Third, it results in a fundamentally better quality product. It works better, feels better to use. This leads directly to greater customer satisfaction and loyalty. People stick with products they enjoy using.
And that likely translates to market share.
Exactly. Increased market share is often a direct result. But beyond the business case, it also means fewer errors in those critical systems we talked about, which means greater safety. It means more inclusive products that empower people with disabilities. It contributes to a better, more usable digital world for everyone.
So, wrapping up this deep dive, it feels clear that understanding HCI and UX isn't just, about making nice-looking apps. It's much deeper than that. It's about safety. It's about inclusion and accessibility. It's about connecting globally. And really, it's about the fundamental quality of our interaction with the technology that increasingly defines our world.
It really does shape our lives in profound ways, often without us even noticing.
Yeah. Which leads to a final thought for you, our listener. Now that you have a better handle on the impact of design from the smallest button to the most complex system, how might you look at the interfaces you encounter every day a bit differently?
Think about it. Where might an unexpected design choice, maybe brilliant, maybe awful, be subtly influencing your day?
Yeah.
In your car, at the grocery store, self-checkout, on a medical device.
We encourage you to become a more mindful observer, maybe even an advocate for good design, not just on your screens, but everywhere technology touches your life.